All right, let's get right into it. Today, we are talking about what is, in my opinion, the single most misunderstood danger when you're putting generative AI into production. We hear all about the crazy stuff, but the real threat? It's hiding in plain sight, right at the point where we decide to give our models real power.
So let me just ask you this straight up. When you think of a big AI model failing in the real world, what's the first thing that pops into your head? For almost everyone, it's hallucinations, right? The model just making something up. But what if that's not the real story at all?
Here's the punchline. The biggest risk isn't the model giving you a wrong answer, it's the model taking a wrong action. We're not talking about the model just saying something incorrect anymore, we're talking about it doing something it absolutely shouldn't. This is a whole different ballgame. This is about capability failures.
Okay, so let's unpack that. The entire risk profile of an AI system, it just completely flips on its head at one single critical moment. The moment you give that model access to tools. This is when it stops being a fancy text generator and turns into an active agent inside your systems. Just look at the difference here. On the left, you've got your standard sandboxed LLM. The absolute worst it can do is spit out a weird or wrong sentence. It's annoying, but it's contained. But look at the right. The second it can call an API, or trigger a workflow, or query a database, a failure is no longer a wrong answer. It's an accidental order, a deleted file, a leaked record. It's a potentially catastrophic action.
So here's the mental shift we all have to make. We have got to stop thinking of these things as just models. As soon as it can use a tool, it effectively becomes a privileged microservice. It's a live component making decisions, and remember, these are probabilistic decisions deep inside your architecture. You would never, ever let a brand new intern have that kind of unchecked access, so why on earth would we give it to an LLM?
And that brings us to what is frankly the most dangerous mistake I see teams making over and over again. They try to control this incredibly powerful new microservice with the one thing they're comfortable with, the system prompt.
Oh, you've seen this 1,000 times, right? A big block of text in the system prompt, just full of good intentions. You are a helpful assistant. Please be nice. And pretty please with a cherry on top, do not query the user's table and email it to a stranger. It feels like it should work, but it is a fundamentally broken approach to security.
And this slide just nails it. A prompt is documentation, it's a list of suggestions, it's a wish list. It is not, and it can never be, an enforcement mechanism. You're just crossing your fingers and hoping the model feels like following your rules today.
So let's get into the nitty-gritty of why this fails. First, LLMs are probabilistic. They don't follow rules like a computer program, they make a best guess. Second, they can be socially engineered, tricked with clever wording. And the big one, prompt injection. This is where a clever attacker hides a command inside their own prompt, basically tricking your model into ignoring your instructions and doing their bidding instead. Your security has to live outside of this mess.
So, if prompts are just hopes and dreams, what's the real answer? Well, you have to build a wall, not write a longer list of suggestions. This is where the capability boundary system comes in. It's an external layer of pure governance that enforces hard, unbreakable rules about what the model is and, more importantly, is not allowed to do.
Now, at the very heart of this system is a beautifully simple idea, the tool contract. Just think of it like a configuration file, a machine-readable agreement for every single tool the LLM is allowed to touch. This contract doesn't suggest behavior, it explicitly defines permissions, it defines data access, it defines limits. This isn't just some metadata. This file is the literal technical definition of your system's attack surface.
And here's what that looks like in the real world. For some kind of database tool, the contract can specify, right here, that it's read-only. And look, it can only touch these specific tables, orders, and products, nothing else. And we can even throw in a rate limit to prevent abuse. It doesn't matter what a clever prompt tricks the LLM into wanting to do. This contract defines what it physically can do.
Okay, let's walk through this step by step, because this is the magic. Step 1, the LLM, maybe it's been tricked by a prompt injection, tries to do something bad, like query the entire user's table. Now here's the crucial part. That request doesn't go to the database. An external permission engine grabs it first. That engine pulls up the tool contract we just saw, compares the request to the rules, and immediately sees, whoa, the user's table is not on the list. And boom, access is denied. The attack is stopped before it even begins.
So once you make this architectural change, it completely forces you to rethink how you do testing and validation, especially in a CI/CD pipeline.
we have to get beyond just asking if the model gives the right answers. This slide just lays out the shift perfectly. The old way, what we call behavior testing, is all about asking, does the model know it shouldn't do this? It's a test of its knowledge. The new way, authority testing, asks a much more powerful question. Can the model do this, even if it tries with all its might? You're not testing what it knows, you're testing the hard limits of the system you've built around it.
So what does all this add up to? Well, it's a fundamental shift in our entire mindset. It's about evolving from an academic focus on model accuracy to a hardened engineering focus on system safety.
For years, AI research has been obsessed with the question on the left. Can the model get the answer right? But to be truly production-ready, the only question that matters is the one on the right. When this model inevitably gets it wrong, what is the blast radius? What's the maximum possible damage it can do? We have to assume failure will happen and engineer for safety from day one.
And that is the real power of this whole approach. Tool contracts give you the power to explicitly define and shrink that blast radius before a single user ever touches your application. You are no longer guessing or hoping. You are engineering a system with predictable, contained, and survivable failure modes. That's what lets you ship these incredible models with real confidence.
So we'll leave you with this one final thought because it really says it all. The danger was never that these models can be wrong. The danger is giving them the unchecked power to act on those mistakes. By managing their authority, not just chasing their accuracy, we can finally turn these powerful but risky experiments into robust, production-ready systems. And that, right there, is where true AI readiness begins.